right, so today we have Kostas Paralis. He is one of the founders of Typedef, which you can find at typedef.ai. Descriptions on the website, the AI data engine for modern workloads. And they also have an open source project called Fenic. And if you go to the GitHub repo, some of the descriptions there are that Fenic is an opinionated PySpark inspired data frame framework for building AI and agentic applications. So with that, Kostas, welcome to the podcast.
Thank you so much for hosting me here.
And I guess let's start at the beginning. So was there a personal kind of experience or aha moment that convinced you folks that these existing data platforms are just not enough for the AI era, and therefore we need something like Fenic and Typedef?
Yeah. I mean, the short answer is yes, but I think it would be helpful to give a little bit more context. So both me and my co-founder, we've been in the data infrastructure space for quite a long time. My first company back in 2014, Blender, was a cloud DLT solution, so similar to Fivetran, it stitched data. Then worked as like part of the leadership team at Rudderstack, again around like ingestion. So we were collecting like customer events primarily there and ingesting them to downstream systems like data warehouse and data lakes. And then after that, I joined the team at Starburst Data. Starburst Data is like a company that is monetizing Trino. Back in the days when it was first invented, it was called like Presto at Facebook back then, Meta today.
No, I was the program chair of Strata, so all these companies are familiar.
Cool, perfect. So you know them. So yeah, as you can tell, I've been I've experienced, let's say, the development and progress of like working with data like firsthand, primarily as a builder, right?
Mainly structured and semi-structured.
Correct. That's absolutely correct. But one of the things that was starting to get, let's say, more and more evident, and that's before the AI, to be honest, right, was that if we take a step back and see like when these technologies that we use today, like Spark, like Trino, like even like Snowflake, Redshift, all these technologies, they were starting to get built at a time where the use cases were like very, very different, right? Like the dominant use case was like BI, right? Of course, ML came in a little bit like later, but ML remained more of like a smaller use case for a very long time, right? So more and more like use cases were like coming up that were important, but didn't have like the critical mass yet to spark, let's say, like the innovation of like new systems out there. So we were trying like always to use the existing technology and somehow make it fit to these use cases, right? ML is one good example of that. Embedded analytics is another one. We started at some point talking more about, like data is more of like a product, right? And when we say product, we mean that the customer is actually interacting with that, not just like for internal use cases. But what happens when, and that's why we started like Typedef, by the way, it wasn't because of AI. We were just, we thought that there is like an inflection point right now in the industry.
Roughly, what year are we talking about? This was ChatGPT already released?
Yeah. So I started working with my co-founder here like 2 years ago, I would say. So the first wave of like AI was like already out there, but we started, let's say, like Typedef, not because of the AI, but because we had a broader belief that the market is changing, the industry is changing, data is going to become, let's say, the core of delivering value instead of software as it was like before the last like 15 years. So there is a great opportunity here because we need new tooling. We need new tooling both for the new use cases, but most importantly, for new people, for more people to enter this space, to be able like to have instead of like hundreds of thousands of people, millions of people, like similar like to what happened 2008, 2010 with like the application engineering, right? But then AI also came in and acted as a catalyst. So what would probably take a couple of years to start like being more like realized as a change actually happened in months. So yeah, that's let's say the intuition and the experience that made us say, yeah, like we need to think from first principles and not just take an existing tool and try like to make it fit in these new workloads that we have.
By the way, full disclosure, I'm an advisor to both Databricks from the beginning and Anyscale, so creators of Spark and Ray. So it sounds like at a high level, it sounds like you're still mainly focused on structured and semi-structured, because you're talking data frames, right? So
Yes.
tell us what's new, and what and you folks also use this phrase inference first.
Yes, correct.
Right? So what's new in the structured, semi-structured world that necessitated Typedef and Fenic?
Yeah, that's very interesting question. So there is a very core belief and thesis that we have in our product, and that's that when you work with unstructured data, right, especially when you do that at scale, the goal is to take this unstructured data and make the information that they hold from implicit information to explicit information, which also ends up like having structure. And the best way like to do that, and that's like part of like the magic, I think, and a lot of the value that LLMs and the transformers like bring, is that you can actually do that. So we are not focusing, I mean, we believe that the structured and the unstructured world, they need like to merge together, right? So that's what we are doing here. And someone can see that by the fact that we pay a lot of attention on our like type system. So if you see like the types, we introduce new types for transcripts, for example, or types for Markdown, right? Similar like how 10, 12 years ago, like the database people were like, why do we need JSON? Like we have relations, but the market forced like the databases to start considering JSON as a first-class citizen. Now we have to do that again, right? With, let's say, the types of data that because of inference, because of LLMs, they become much more important. And I think Markdown is a great example of that, because Markdown like started primarily and still is like a format for styling, right? Like you describe how to style like your document.
It's for blogging.
But because of
originally for blogging, right? So, yeah.
Exactly. But now, because of LLMs and because of how much they've been trained like on these, we don't treat them only as like styling. There's also structure that they encode, right? So you have code snippets, you have sections, you have paragraphs, you have bullets, you have all these structural information, which can provide like a lot of value when you're dealing with this data. And that's how we are entering, let's say, like the space of like unstructured data. So we are not yet, at least, like have a way to represent like images or videos, but this is part of like the roadmap. But the goal always is, in our opinion, how to start from this raw binary data that you have and start adding more and more structure where you can leverage both LLMs, obviously, but also traditional ways of like processing the data and do it in a very natural way. That's where the inference-first comes in. Inference is just another form of computation that the query engine exposes to you, but the user doesn't really have like to care about that. It's like, doesn't matter if it's a CPU or like it's like RAM or like there's inference too there. And the way that we do that is by encoding let's say, inference in the operators of the query language that we have. So instead of building just like UDFs that are more like black boxes to do the inference, now you have things like semantic filtering, as we call it, or semantic joins. But this behind the scenes, or semantic map behind the scenes, what happens is that it kind of gives a template, right, on how to do inference for specific tasks. And the user will, of course, create like and provide like a prompt, but things now are like more guardrailed and easier like to reason about from the human perspective and also the query engine perspective too.
By the way, this is fascinating. So a while back, I wrote a post called "Structure is All You Need."
Yeah.
Because basically, I started observing, right? So you have all this unstructured data, but inside the unstructured data, there's actually a lot of structure, right? So at the extreme level, one manifestation of that is people started thinking about knowledge graphs and graph RAG,
Yeah.
right? So if for some reason you are able to create a knowledge graph out of your unstructured text, that's great. But and depending on the level of precision of your application, that's actually doable if you are tolerant of less precise
Yeah,
knowledge
of course.
graph, right? So, but then also, short of a knowledge graph, there's all sorts of information inside, like hierarchical structure that you alluded to, right?
Yep.
Chapters, paragraphs, uh,
Yep.
and then inside the unstructured text, there might also be, implicit structure like charts and
Correct.
things like
Yeah.
this, right? So if you can do OCR, and obviously that doesn't even include the metadata, right? So that you might be able to mine. So yeah, so this is all. So it sounds like what you folks are doing is trying to formalize this and make this more rigorous. This process of taking something that's seemingly unstructured and extracting as much structure out of it.
Yes. Correct. Correct. And give the right tools to the engineers to do that actually, because I don't think there is like one solution that fits everyone, right? Like the domain experts, engineers, like the best people like to figure these things out. And I think there's so much, how to say that, like wisdom built around building software in production, right? All these years that if we take them and apply them, like with inference also in mind, it will help us accelerate like the time to get all these projects into production at the end of the day. I think I hear people like having hard time, like, like with LLMs, like easy to make demos, but like when you have to get into production, that's where like things get hard. And I think big part of that is not because these systems are just not deterministic, which sure they are, but the software industry has been building like working and operating systems that they are not deterministic for a very long time. It's not like we don't have the wisdom and like the knowledge like to do that. We have, of course, to apply it to LLMs and inference. And that's why the data frame API comes in, why we said, let's build on the data frame instead of doing something like of our own, right? It's part of whatever is like most familiar for the people out there already, and whatever already has built an ecosystem. And when I say ecosystem, is also the knowledge that the institutional knowledge like people have built, like the companies have built around operating these systems. It's extremely like valuable right now if you want to do the next step and start putting these things like into production.
So I think for our listeners out there, I think it's intuitively clear that if you are able to extract structure, obviously that allows you to provide better information to the LLM and context and all of that, right?
Correct.
So obviously uh, as much information and guidance you can give to the LLM, the better your application will be. I think that's intuitively clear. So, Kostas, for our listeners who haven't tried Fenic, can you walk us through like a hello world example? So, what is the easiest way to think of this if you work through an example and then you see exactly what it's about?
Yeah, yeah. So we have,
So
by the way,
I guess let's say I have a bunch of PDF files. So then what?
Yeah. Okay. So you have a bunch of PDF files. Let's take the example of we'll build we'll go from like a simpler case to a more like complicated and see like how things build up. So we have a bunch of PDF files, right? The first thing that you want to do is like use some like either OCR if you want to do that, like an OCR library, or like a model that performs like OCR, like the Mistral one or something else, that you will feed the PDF in, and that will give you back some markdown representation of the document. Now, the beauty of having like a data frame API, which is in Python, is also that you can very easily write mix and match like imperative code that, for example, call like a local like model if you want, or like go and use like the Mistral to do that. So when you get the raw output from there, you can go and like store it inside like a data frame, like a Fenic data frame, and set it up like the data type to be marked down. Now, what that gives you is that, and the philosophy might sound like a little
So
bit.
how is the data laid out? So a single PDF file is stored in one cell in a data frame?
Yes,
Okay.
yes. Yeah, that's how you start, right? And for people who have used DuckDB with JSON, the process will sound like a little bit familiar. So you have this, let's say, logical data type, which is the markdown. The goal is with like a rich API around interacting with it to end up in a very structured and rigid schema, which is going to be structs and arrays and like all these things that like the system then like can reason about. Now, there are like column functions that they are specifically like operating like on Markdown, right? So for example, you can query and say, okay, I want to go and extract all the headings, for example, which correspond like to the sections. Or think of it as like
this is built in Fenic, built into Fenic.
Yeah.
Okay.
Yeah. Or I want to create a table of contents, which is many times like super useful. And you can do that across like the whole column. So if let's say you have many different PDFs, but they are kind of like the same domain, right? You can create kind of like an abstract at the end of the day very easily that then you can use that with LLMs too, right?
And this is because the secret sauce here is you're getting deep into the markdown.
Yes, correct. We are considering Markdown pretty much as like you could think of like JSON in a way, how you work like with JSON, but with all the nuances that like Markdown has, right?
So let me ask you this. So there's a bunch of open source projects out there that are, trying to take unstructured data, right? And make it more usable for PDF files, right? So let's see, docetl. I'm not sure if you're familiar with that. Docetl.
There are like a couple of them.
Unstructured or something like that. So how is what you're doing different? So are they not focusing on Markdown as well?
I would say that when it comes to them, I think of them more as like the ingestion layer, kind of like how, let's say, Fivetran was like taking the data from like Salesforce and ingesting it into like a query engine. Fivetran was still doing some transformation, like doing that, right? I kind of like see these systems like in a similar way. And that's why, by the way, we're not opinionated or have like any heavy functionality about acting on the PDF file itself. Like
So
the user should use.
you're not doing actual information extraction. You're just taking, here's the PDF file. We'll convert it into Markdown, and then
Yes,
we'll go from Markdown.
yes,
Whereas these tools do information extraction. They'll go in, try to analyze the charts, and
yeah. I mean, they can do that, and then use something like Fenic to post-process that and make it like run more tests and like correct issues or apply different schemas and do this kind of things. Or if someone
schema,
wants
where
to have,
schema here is schema in the context of Markdown.
I would say it's like the schema that the user wants to have as the output to process in a structured way the data, but wants to fill this schema from data that comes from the documents, right?
So the user of Fenic then will go, here's a bunch of PDF files. What I really want at the end of the day is the following. That's the schema, no?
Mm-hmm. Yeah,
Okay.
yeah. And you can define the schema like in Fenic, and you can populate it and all these things. Now, the user has the flexibility to either, let's say, if they want to use more of like an out-of-the-box solution that goes from PDF to a structured output like in JSON or whatever, they can use that and then post-process after that using Fenic.
What does the post-processing using Fenic do? What's the advantage?
So the advantage there, if we are focusing just like on the PDF themselves, has primarily to do with applying evals and fixing issues, because none of these systems are like perfect, right?
Oh, yeah.
Exactly. And I think like the problem when you build like a point solution that is doing that, you have to always find, let's say, the average that can be good enough for everyone, right? But there's definitely need for fine tuning like after that, especially like in cases like we're talking with people that are in healthcare where, okay, the accuracy that they want like has to be like extremely high. So they do have issues when like these systems are good enough, but they are not good enough for them. It's like good enough like for the average market out there, right? So people still want to be able to have more control over understanding like how the data looks like, run their own evals, do the process there, and of course like the rest of the processing downstream, right? Like that's the beauty of Fenic.
So how do you do evals in terms of so evals to me could be a case of, you miss some key piece of information, right? So that it's in the PDF, but somehow you're not able to extract it.
Yeah, there are different ways that these things can be done, right? Like, and that's, I think, like the power of using, like having an expressive API, like Fenic and like the data frame API. So people can use, for example, they have their own eval like golden data sets that they can go like and evaluate, and they can build this evaluation like using Fenic. Like Fenic allows you in the same like session to use multiple different.
Once you do the eval using Fenic, then you can start diagnosing. You go, so the problem was the OCR library that we used.
Yes, correct.
Or you can at least, where the problem is, and then you can diagnose as to possible solutions.
Yeah. And two important things here. There are like two features in Fenic that I think they are like extremely important for this type of work. So Fenic has like a built-in concept of like caching. So when you have your data frame and you have your codes, which naturally is a graph, right? And it's like lazily evaluated. So, and that's what we encourage like people do, is that whenever you do some inference, you can cast the output explicitly. You can say, okay, at this stage, now we want to cast the example, the output. what happens here, like, and that's like especially important, like during development, is that, okay, my processing requires, let's say, 5 steps of inference, right? Like first I extract some information using like an LLM. The second step, I do some filtering. Then I might do some similarity join or like a semantic join. We can talk more about what that is, or like some clustering. The idea is that like each one of these steps, right, depends on the previous steps, and it's also doing inference. So by casting the previous steps, what you achieve is like there are like 2 important things that are happening. One, you keep the data that has been generated static, so you can focus on what you are building right now and the prompt that you are editing right now without having the whatever like slight changes might happen every time you do the previous inference, like affect what you're doing. And the second is performance, right? Like if you, as you add more and more inference steps, if you run the inference again and again from the beginning, like your pipeline while you're developing is getting like slower and slower, right? So that's one thing that's like quite important. The other is something that we call like row level lineage, which with inference is like quite important when you want like to debug things. So people who are experienced with like data infrastructure, they know that like until today we are using like column-based lineage, right? And it's really important when we try like to debug issues. This works great like in a lab world where whatever you're doing, it's going to apply on the whole column, right? And it's pretty much the semantics are the same. But because of how inference works, and because your prompt is pretty much like changing with each input row that you have, a column level lineage, like it's not going like to help there like to debug. So what we have implemented is row level lineage. So now you can be, like I ran this pipeline and this particular output here looks weird. How was this particular output like generated? And the system, we can create like a graph of like all the processing that all the data from the beginning of the execution until you got the end result can be presented to you with all like the prompts and all the parameters there that were present, which is really, really powerful in like debugging multi-step systems that each step has its own like inference that feeds to the next one.
By the way, so when data frame, right? So when people talk of data frame, you know, the things that come to mind are Pandas API or Pandas, right? So, or SQL. So,
yes,
right. So I guess in this context, you have unstructured data, you stick it into a data frame, and so then how do you explore the data frame? So before you do anything more, right? So usually, in the case of structured data, when you load something into a data frame, what's the first thing you do? Well, the first thing you do is to run some diagnostics, exploratory data analysis, see if there's something weird, right? So what exactly? So what? I guess I'm not clear on the why data frame.
Oh, why data frame?
And is data frame used because you know, traditionally, like I said, in data engineering, people use data frames, and the first thing they do after loading a data into a data frame is run some diagnostics. So is that kind of what's happening here?
Yeah. We want to take the, let's say, the knowledge that people have on like how to build around data and apply that and extend it when inference is also part of that, right? And I think like the data frames have like a couple of like benefits, like compared to.
By the way, I'm still clarify against this inference notion.
Okay.
Yeah.
So the inference notion, I know like for ML people might be a little bit confusing that we say inference, but when we are saying like inference, we primarily mean having access to LLMs and mix them in the processing of like building like a pipeline. And as you do your joins, your filters, all the standard things that you do,
Because
you
in
can
this
also,
because in this context, every step of the pipeline, you're actually doing some sort of inference. Because
you can.
you might be relying on a model, right?
Yes, and it's our like engineer, like the developer who's using it, it's their choice like to put inference in there whenever they want. You can absolutely use Fenic without any inference at all if you don't want to, right? It's like as you would do with like PySpark or like Pandas, and you want to crunch some numbers, you can absolutely do that, right? And that's our starting point. We start from that, and we start adding building blocks there for people to also add, let's say, inference in the mix. So now that I have this column that is, let's say, markdown documents, right? And I want a summary, right, for that. What is going to happen is that I'm going like
And
to
that's
ask.
inference.
That's inference, exactly. Yeah.
Yeah.
But after you do your summary,
And that's only possible because Fenic is able to feed better data into the model. Once it's stored in Markdown, you can feed better information, better context to the model to provide better summaries, right?
correct.
Yeah.
And we give the tools to the users like to have to define that context like as they desire to make like like to get the results that they want. There's nothing. I think when you are dealing with engineers, it's important to give them tools and not black boxes, right? You need to have the right defaults and abstractions there for them like to not get frustrated when like the same thing needs to be like tweaked like every time. But at the end of the day, their job is like first to understand what's going on when you operate. That's why we have these features around like row level lineage, like the caching, all the debugging, and to support like better evals at the end of the day. And on the other hand, we have like an easy API that they are already aware that they can go and start building. But when they want to go deeper, they have the tools like to go and change how the system like operates.
I guess let's try to frame this a slightly different way, which is in terms of applications that people are familiar with, right? So, for example, I have a bunch of PDF files. I could do I could build a simple RAG application without
Yeah.
Fenic and a RAG application with Fenic.
Yes.
What would be the difference? Qualitatively. So before we go
Yeah.
into the steps, but what would be the difference in user experience?
Yeah. So the difference will be you have a system that has the right abstractions there, like to go and do things, let's say, in a more with much less like boilerplate, focusing more on like what really matters.
And what's inside the documents and how they're related, right? Is that
Yeah. Now,
because
like,
traditional rank will just go in there and start building embeddings and not really be aware of
correct
the context of the parts of the document, right?
Yeah. Like one of the first things that like got me like a little bit frustrated in a good way was I was like seeing like all these tools out there, like let's say LangChain, for example, right? And you have to do chunking, and chunking you don't do it only for the reasons of like the context window that the model has, because let's say you might have an infinite size of the window, but it's also like very important for the quality, right? But if you see like the chunking that is happening is very, I would say, naive in the sense of like there's so much more information that you can use to chunk your document, right? Like why I wouldn't do it like on per section, for example, or per like. But in order to do that, either you had to go and build a lot of like custom logic on top of that, like to try and like figure out the structure. But if you do that, then you start getting like a lot of.
Whereas you guys give that to me for free.
Yeah, exactly.
Right. And then that means that I think now that people are aware that in applications like RAG, because you have so many knobs you can turn, like you said, chunking, embedding, right, and so on and so
Yes.
forth. It's really you should think of it as an end-to-end system, an end-to-end
Hmm.
pipeline that you optimize the pipeline end to end.
Yes.
And so if you have a tool like Fenic, which is injects rigor at every step of that pipeline, then you're more likely to get into a scenario where your RAG application is optimal.
Correct. Exactly. And I would say that's one thing. The other thing is that no matter what you build, at the end of the day, you have to operate it, right? And these systems, their behavior needs like to be adapted because your data changes or your requirements change, right? And the problem that you have with the existing solutions out there is that because of like the how many different systems you have like to put together, and how much like of a black box they are, it's really hard like to operate them and have the, let's say, observability or like the visibility into what is going on there to both detect issues like fast enough, but also reason on what you have to change in order like to improve things or like fix things, right? And with a lazy API like the data frame and something like Fenic, you kind of get that like for free, right? And most importantly, because of this inference first thing that we are talking, which means that the query engine itself, it is aware that this operator now is going to do inference. It's not like a UDF, which is black box, which is, let's say what, like if you have Spark, right? And you go and build like a UDF, like to go and do like inference. The problem with that is that Catalyst, which is like a piece of art when it comes like to an optimizer, it's completely oblivious of like what is going on there and like what to do with it, right? So it cannot touch it. So what we do from our side is that let's change that. Let's make the operation, the inference operation, something that the optimizer is aware of, and it can take care of things as queries and databases were doing in the past. So remove a lot of like, let's say the mental overhead that the engineer has in order like to optimize things, and at the same time give a much richer insights of what is going on there and being able like to go and debug it or improve it in the future. So that's where, like, I would say the most important part, which it's a little bit like more like from the systems and like the databases world, like comes in when we say like inference first, and why we are like so obsessed with considering inference as the same as CPU processing and having things like the data types and all these things is because at the end of the day, we are able like to build a system that can reason about what the user is trying to do and optimize it on his behalf. So he doesn't have like to focus on that anymore and can focus on the really hard problems, which is this output correct? Or should we do something else?
Have you folks had to worry about scale? So in other words, have you had anyone try to use Fenic with, I don't know, millions and millions of PDF files?
So the scale
I
is
mean,
an
it's not
interesting
something you
problem.
have to tackle until you have to tackle. You know?
Yeah, no, 100%. But I would say, as a person who is coming also like, I mean, I've been, worked with systems like Trino that they can scale to extreme levels,
Or
like when it comes.
in this context, you have things like Ray data, right? So
Yeah.
that can help you, right? So
I think like the limiting factor there, like the data itself and the operations that are happening on them are not that hard to scale because
it's the
they are
LLM, the bottleneck will be the LLM, right?
correct,
Yeah, yeah.
exactly. And that's like
And
another.
not just
Mhm.
bottleneck in terms of scale, but also you start worrying about the cost too, right?
Yes, 100%. That's where like the optimizers will become like really important. I think if you see like the industry right now in the state of the art, you will see that there's a lot of work that is happening to optimize inference with like VLLM, and all these systems out there. But I think there is an opportunity there, especially for batch processing use cases, where when the query engine is aware also of the inference engine, because you know the whole end-to-end processing that is going to happen, you can do a lot of optimizations to help a lot like the inference engine on the other side too.
You might be able to get by with much smaller models.
Yes, that's
Right,
true
so-
too. Yeah.
I mean, because if you understand your data well enough, you might be able to post-train your model so that it's better.
Yeah, one of the...
By the way, so one question. So I early on I mentioned this notion of graph rag and knowledge graphs. Is Fenic going to help me create a knowledge graph out of my unstructured data? Is that something that people have asked you about?
Not really, to be honest. Like, we don't have this kind of like conversations yet.
You know more about my documents than
Yeah, that's true.
than most tools, right? So maybe
Yeah.
if I take that, even the step one of Fenic, where it turns it into Markdown, that might help me in my knowledge graph creation, I would imagine, right?
Probably. It's just, I mean, if people from your audience like are interested in this use case, we are more than happy like to discuss about it. I think there are like
point some people to it. By the way, so multimodality. So are you completely focused on text? No computer vision?
we are focusing
no audio?
we are focusing on text right now for a reason.
There's no markdown.
No. It's not about that. I think you can turn everything into Markdown if you want. But I think the reason we are focusing more on text right now, it's primarily like a constrained optimization that we are doing in ourselves, because building a query engine from scratch is already like pretty hard. Trying to cover everything is almost impossible with the resources that we have. The reason we chose text, I would say, is because if you think about most of the cases, because the API with the LLMs anyway is text at the end of the day, in most of the cases, for us, it's like a good building block to start and bootstrap like the development. And then
you're a startup, you have to focus, right? So
exactly. So PDF, right? It's binary data, but at the end of the day, you will do your first pass of like OCR or like fitting in, like a visual, like capable LLM or whatever. You will end up with text again, right?
Are you able to do any sort of entity resolution?
Actually, there are some use cases in the examples that I have in the repository of Fenic. We have at least one example of like how to do named entity recognition and resolution. We don't have, again, the out of the box, like we don't have a function called named entity resolution.
Or it could be the case that, there's also best of breed tools. So if somehow you can integrate with some of these best of breed tools for entity resolution or some other thing.
Yeah, we could do that. We have at least like one like design partner like right now that we are working with, where named entity resolution actually is like a big part of what they're doing. But again, I think because what is happening is in their case, they need like to focus like a very specific domain that they have. So Fenic for them and like Typedef is like perfect because it gives to them like all the tools to go and customize the named entity recognition like for their domain specifically, instead of like trying to use like a more generic solution.
So of course, in the data infrastructure world, right? So the kind of center of gravity is the Lakehouse, which by the way, I helped coin that term with the founders of Databricks.
Nice.
And now there's notions, and a lot of the Lakehouses are built on Parquet and
yes,
And now there's the notion of the multimodal Lakehouse,
Hmm.
and Lance file format is built on top of Parquet as well,
Yeah.
but supports better suited for full table scans and search for multimodal data. But
Hmm.
you know, key thing there is you have an open file format, you have the separation of data and compute,
Yes.
right? So how does Fenic fit into that data stack?
Yeah. We we embrace this architecture and vision like from day zero, I would say, because we are kind of like children of that.
And then that's your users are using that.
Yeah, yeah, and I think it's I think there's no going back from, let's say, the separation, at least like from storage and compute, right? And that's a good thing, primarily because building efficient storage is an
Sorry,
extremely
Teradata.
hard problem. Hmm?
Sorry, Teradata.
Yeah, I mean, they're doing good. Like if you think like for how long they've been out there, like,
Yeah. Yeah.
but
Anyway.
yeah.
Yeah.
So
What
I think
about
there's no going.
people are kind of rallied around open file formats like Parquet.
That's an interesting topic. I think there are like two forces there. So you have the people like Cheng, who is an amazing person, like Lance DBs, and the file format is like an amazing innovation.
I'm an advisor as well. Yeah. Yeah.
Oh,
Yeah. Yeah.
you that's great.
Yeah.
He's a great person and a great like company. It is hard though, and like I literally, I mean, I admire what he's doing. I think like trying to compete with Parquet is
No,
is almost
he's
crazy.
built on top of Parquet, right? So
Yeah, but like you have to copy the data, right? Like
yeah.
it's not
Yeah. Yeah. Yeah.
like on Parquet itself.
But then
It is like
he's targeting different modalities anyway, right? So
yes, that's true. And there are like people also in
he
the.
might still be a complement, right? So
I mean, I think he has to at the
yeah.
beginning, at least.
Yeah.
By the way, there are like other formats too. Like there's like the alpha format, like from Meta, which I think they changed the name also to something else. They love changing names.
Yeah, but the
And
industry is coalesced around Parquet, and then obviously the Lakehouse formats on top of that, Iceberg,
yes,
Delta, and Trino, right?
yeah, yeah,
Iceberg, Delta, and Hoodie, right? So
yeah, correct. There are like people also, like especially I think like from the academia, that they say Parquet is flexible enough to build on top of Parquet these multimodalities if you want. Now,
that's why I don't understand the duck lake. I understand. Okay, so put the metadata store in a database. That's fine. But then they didn't embrace the file format.
yeah.
Right? So,
Um,
which a lot of people are already comfortable with. And then a lot of the things that the issues they raised, I believe the Iceberg and Delta people are going to address. So,
yeah, and I think there are opportunities out there for like these new workloads, like for LanceDB, for example, where there are problems with storage at scale, at least that Iceberg and
so
Delta and
how would
Hoodie.
you guys fit? I'm in a lake house, so how do you fit in?
We're not. We're purely on the compute side.
Okay.
We do the compute. Like the storage should be a problem solved by the people who know best how like to do that. Like for that reason, like we won't like to be very well integrated with like Iceberg, with Delta, with like Lance. Like the customers should have the flexibility to choose what kind of storage they want and need. And we should be able to be performant regardless of what they're using.
And Fanic is written in Rust. Is that right?
Yes, there's Rust, there's Python on top of it. We are, of course, and I have like to say that because the unsung hero of like all this space is Arrow. I think like without Arrow, none of that stuff would be where it is like today. We've been using like polars. There's like a lot of let's say like interoperability that we implement
We need to get
between.
you. We need to get you guys using Ray too.
We do. We want that. I mean, for the platform where we want to start like building the like Fenic right now is something that you would use like locally, right? I mean, it scales in one node pretty well, but we are building also the cloud platform, and their scale is an important thing, and like Ray is one of the like the technologies that we are like considering of like building on top of,
Yeah,
right?
I can introduce you to them.
Please do,
So
please do.
so in closing, so you folks have been around for a couple of years. So
I mean, we've been like I would say the company is like 1 year old.
1 year old. So
Yeah, we're young.
you have people early users of Fenic.
Yes, we do.
So what are the 1 to 2 coolest use cases of Fenic that you like to brag about that you guys had nothing to do with, that one of your early design partners did?
Yeah,
You don't have to describe the details of the technology.
yeah.
What application did they end up building?
Yeah. I think I'll tell you like two of them, which I find like extremely interesting. One is like coming from content, like companies that they are exposing content out there. The biggest, I think, like revolution that can happen in these places is that the content had to be organized, right? To give it like to users, create like recommendation systems and like all that stuff, like hierarchies, like to find like topics and all these things. But actually now with LLMs, we have the ability to go one step further. And instead of having like these static, let's say, taxonomies that they give you an idea of what the topic might be about, but it's very, very like
Very rigid. Yeah.
yeah, exactly. You can actually start extracting narratives and create like narrative arcs. Like you can see create like the evolution of how, let's say, a topic evolves through like time and how it changes. These are like things that, and the best part in my
The user in this case, was it a consumer-facing application that they end up building?
yeah. And they are kind of like rebuilding like a much more sophisticated like classification system, which is dynamic about like the content that they have. So the user can also get access to not just like a topic, but also to see how the topic evolves in time, right? And get more of
This is for free. Before you had to do that all yourself using temporal topic models, and it was complicated before, right?
yeah.
And
But now
now
you have the tool.
this just comes for free with Fenic in some ways.
I mean, you still have to, let's say, work on like figuring out like the context that it's right for your domain, right? But these are like things that previously, even for very large enterprises in the media, were like extremely expensive and hard like to do fast enough because news like changed like really fast, right? But now literally you can have like a narrative arc that almost like updates on real time when like new news happen, right?
So if you have a
So
consumer-facing site, then your site would reflect that, right? Yeah.
exactly.
And what's the
Um,
second example?
the second example comes like from cybersecurity. I was always like feeling that cybersecurity is like a data problem,
Oh yeah, massive
and
data problem. Yeah.
yeah, and always that
That's all they do, by the way. They have security analysts that do investigations, and
exactly.
investigations are data
Yeah, exactly.
intensive, right? Yeah, yeah.
Exactly. And even before LLMs, I felt that there was like a lot of the tooling and the techniques like from the data world that they could be amazing, like applying them in cybersecurity. But I think now with like LLMs, it's like even more profound. They're like the name entity recognition, for example, like or extraction. For people who don't know, like the cybersecurity community is building constantly and maintaining databases, right? That they are always a mix of unstructured and structured data. And this unstructured data, they have all the juice of like what you need to understand in order like to go and find something or detect something. So there's like a huge opportunity like to go and process this data, extract structure, as we said, and automate a lot of like the things that were like extremely hard to do at scale like before. So I think the cybersecurity.
Is this, so this is not a, so this is more like an example you're aspiring to, but you haven't worked with anyone in cybersecurity yet.
We
You
are
have,
working.
okay.
Yeah. No, I'm talking about like the things that so far we've seen like with people that we work together, and they're like really exciting. So these like the two that I would say are very interesting, and I think
the common thread, as we alluded to earlier, the common thread in both cases is they have a lot of unstructured data, and they're able to squeeze more out of the unstructured data by extracting as much structure out of it.
exactly correct.
Yeah.
Correct.
And
And I think cybersecurity is a great example of that, because the scale of data that you get is like so large that you could never be able to just throw that on an LLM, ask a question, and hope that you will get a result. Like you need to be smarter on like how you process your data, and also the stakes are like you don't want to make mistakes there, right? But the scale is a big problem. So being able like to use inference when it really is needed, and get into like more structured data that now you can use more OLAP or like traditional ML ways like to process them at larger scale and like with the latencies that are needed. It's kind of like, let's say, the mix that it's going to be like successful in this industry.
yeah, I wonder if knowledge work in general, and then the financial analyst work in particular could benefit from this as well, right? Because financial analysts, they're drawing from all sorts of different data sources, and who knows, they might be leaving a lot on the table if they're
100%.
if they're using other tools. Because I'm sure now they're starting to rely on AI related tools, but those AI related tools might be leaving things on the table, so to speak, right?
Yeah,
Uh,
100%.
yeah,
100%.
and with that, thank you, Kostas.
Thank you so much.